Hey, what's up, guys? Chung here again. So, LeetCode number 1997, first day where you have been in all the rooms. Okay, so this time we have n rooms, right? Labeled from 0 to n minus 1. And then we start from room 0, okay? And we will visit one room a day, okay? Initially, we visit room 0. And the order we visit the rooms is determined by the following rules, okay? And a given index array next visit, right? So if you have been in the room I an odd number of times, right, including the current visit, on the next day you visit the room specified by this next visit, okay, by the odd number of times, right? And then if you have been in the room I an even number of times, then you can move forward, and then you can move on to the next room, okay? So that's the rules, and then return the first day you have been in all the rooms. So that's the description for this problem, and then return the modular, right? So for example, we have next visit 0, 0. So basically, the first next visit is always 0, and this is because this constraints here. Okay, so this next visit will always be smaller than the current index. So which means the next visit can either be the current one, right, or previous one, right? So that's why the first one is always going to be 0, right? So as for the second one, it could be either 0 or 1, because this one is going to be either between 0 and 1, right? So that's why for this one, the answer is 2, because as you guys can see, right? So if everything is following this one, following the next visit is always the biggest one, then what we'll have like for this one, since we can only move forward when we have visited current nodes even number of times. So which means, so here we'll have like 0 and 0, right? So we'll visit 0 twice, then in order for us to move to the next one, right? That's why we move 0 and 0, right? And then the next one will be 1, right? That's why the answer is 2, because that's the first day, because this is 0 day, the first day and second day, right? Okay. And then yeah, so if we follow this example first, right? Let's say if the list is like this, right? And then obviously we'll have like 0, 0, right? And then what? And then we'll have 1, because here, the next day will also be 1, right? So also be 1, 1, right? And then 2, 2, 3, 3, and then 4, right? So if everything follows this, then basically every time we'll only do a +2 to our answer to reach the end, right? But since this one, the next one could be a smaller one, could be a previous one. That's why we have this example, right? So in this case, instead of 1, 0, 1, 2, we have 0, 0, 2, right? So for this one, if we write down, okay, so I think he already wrote it down for us. Basically, we have 0, 0, right? And then the next one is what? The next one, we visit 1, right? But then from 1, right? From 1 here, the next one is what? The next one is 0. It's not 1, right? That's why we'll go back to 0 again, right? And when we're back to 0, we have to visit it twice, because in order for us to move away from 0, it has to be even number of times, because after we move away from it, it's an even number, and when we're back there, we start from the very scratch, from the very beginning, right? And then we move back to 1 and then 2, right? So that's that. That's why the answer is 6. Okay, and then that's it, and then the constraints, right? So apparently this one could be a dynamic programming, right? The only thing is that how can we figure out the state transition function, right? So we have DPI, right? So DPI means that the days that, right, the days that we need to take for us to reach this ice room. Okay, it's gonna be what? It's gonna be a dp I minus 1 plus 2, right? So if everything, like I said, if everything is like this 0, 1, 2, 3, 4, right, then this is a state transition function. Right. Basically, from the previous one, we need another 2 visits for us to be able to move to the next one. Right. But since this obviously this one is not a complete one, because we could have some regression, right? Or because this one could be a going back to a smaller one. Okay. And then how can we do that, right? So let's say from the 3 here, we're going back to 1, right? So let's say from the 3 we have 1 here, right? Or 0. Okay. So what does it mean? It means that it will take us some extra step for us to be able to go from 0 back to here, right? And what was the steps? Basically how many extra days it will take us for it will take us to come back to this day, right? Maybe 1 is better. Okay. Okay. Maybe this one. Okay. Right. It's gonna be for us, how many days for us to get here from the first day to here, right? It's gonna be dp of I minus 1. Okay. So so basically, since this dpi means that to get this current dpi, it means that we have to check the previous index, previous like next value, right? Which means we need to have like a next, right? So it's going to be a next equals to what? Equals to the next visit dot I minus 1, right? So we are at current I here, in order for us to know, so this plus 2 means that, if the previous one is the same, it's the biggest one, right? And then we will not, basically, if the next is the same as I minus 1, if 3 is 3, right? And then basically we don't need to add anything. It's going to be a 0, right? But if this one is 1, in our case, right, then basically this one will go back to 1 and then come back to here. Come back to this 3 again. And how many days will it take? Basically, it will take dp I minus 1, right, minus dp next of days for us to come back, right? Because dpi minus 1 is the ones that is the number of days to reach the current one, right? And the dp next is the number of days to reach to this next, right? And if we do a subtraction, then it's going to be a range. Basically, this one from here to here is dpi minus 1, right? And from here to here is a dp next, right? And then apparently, if we do a subtraction, we get the difference, right? For us to come back from the next day to this dp I minus 1, right? So that's it. So that's the state transition function, right? Move this part to here, and that's a state transition. Okay, cool. So once we figure that out, the implementation is very short. The code is very short here. So n is like this, dp, right? 0. Okay. For I in range of 1 to n, right? We start from 1 because 0 doesn't make sense, because the n is greater than it's at least 2. Okay. And then we have next, right? Next will be the next visit of I minus 1. Okay. And then the dp I equals to dp I minus 1 plus 2, right? And then plus what? Plus the difference, if there's any, where it's the dp of I minus 1, right? Subtract the dp of next, okay, right? And then that's it, right? And then we do a modular. Okay, in the end, just return a dp minus 1 and the modular, right? Yeah, so there you go, right? I mean, very short code. But the key part is to figure out the state transition function, right? And then, so first you have to figure out the basic one, where is if anything is using the max possible next index, which means we'll never go back, right? And then there will be this dpi minus 1 plus 2 plus 2, right? But if we ever went back for some place, and then we have to plus that regression days, right? Which is going to be dpi minus 1 subtract the dp next. Cool. I think that's it, right? And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.